Assalamu alaikum. Have a nice day. I am Adnan Hussain from Pakistan. This is my short demo class in which I want to discuss the topics electromagnetism and electromagnetic induction. I write the main idea in the very simple lines. Current can produce magnet. This is called electromagnetism. Magnet can produce current, and this phenomenon is known as electromagnetic induction. How it possible? Stay for a while. The phenomenon in which an electric current flowing through a conductor produces a magnetic field around it is known as electromagnetic induction. When a charge moves in a conductor, automatically a magnetic field is generated around this conductor, and this phenomenon is known as electromagnetic conductor. This phenomenon was discussed by a Danish scientist, Hans Christian Ørsted, in 1820. He saw a magnetic field around a current carrying conductor by placing a compass needle near this wire. So finally he represented his statement that every electric current can produce magnetic field around itself. But note that the mathematical form was presented by Ampere. Ampere presented his law that when a current flows in a wire, a magnetic field is produced around itself. Magnetic field is presented by B and current is presented by I. Similarly, radius is presented by R. So mathematical form of the Ampere law becomes B is equal to mu naught I divided by 4 phi R. Mu O, it is called permeability of free space. Ampere law is a lengthy topic. I want to cover these topics in a very short time. So come to the practical demo. My lecture is about the magnet, and magnet attract each other iron metals. But if you want to make this wire as a magnet and make it at a helical spring, so it is called solenoid. So we have made a solenoid such that this is a solenoid and it cannot attract iron metals. If we connect this solenoid with a battery, then we can see that this solenoid make a magnet. It will attract the metals. And when we remove the current, so the magnetic effect vanish. So current can produce magnet in a wire. Electromagnetism is used in our life in the shape of electric fans, ceiling or pedestal fans, washing machine, loudspeaker. Similarly, electric door lock. Half lecture is covered, and now go to the electromagnetic induction. This is the next lecture, electromagnetism. The definition is the phenomena in which an induced current or EMF is produced by changing magnetic flux is known as electromagnetic induction. Simply we can say that a magnet will produce a current. How? This phenomena was presented by Michael Faraday in 1831. Michael Faraday was a British scientist, and he noticed that when a coil is placed near a magnet and when we move the magnet forward and backward, so an induced current or EMF is produced in this coil. For more information, let's go to the mathematical form. For the mathematical form, we have a diagram. This is the magnet, this is the coil, these are the plugs. So when the magnet is placed here, so only one plug is passed through the coil, When we go near to the coil, so there are 3 plugs passing through the coil, and here we can see that there are 5 flux passing through the coil. So these changing magnetic flux will produce a current in this coil. Mathematically, EMF, it is also known as voltage or energy source. Minus sign was presented by Lenz, who was also a scientist. N are the number of turns of the coils. How many loops are presented in this coil? Similarly, change of magnetic flux divided by del T. This shows the speed. How fast you are changing the magnetic flux in a coil. So finally, we can say that a magnet will produce electric current in a coil. How? Very easy. Come to the practical demo. This is a galvanometer. We are connecting galvanometer. Note that this needle will move right side or left side when the current is present. For example, now we will produce this current by magnet. How? We have connected galvanometer with the solenoid. This is the coil. This is the magnet. When it is in state of rest, no current or EMF is produced in the galvanometer. But when we move it, we can see that current is produced by changing magnetic flux. So this is the Faraday law. It means that magnet can produce current. This is the motor, this is armature or coil, and this is the permanent magnet. When we rotate this coil in this magnet, it will also produce a current. This is a motor. We connect an LED with this motor. Now we are rotating the armature in this motor. So the LED will glow. How? It means that changing magnetic flux will produce current. The final subtopic is application of the electromagnetic induction. There have a lot of applications of electromagnetic induction, such that electric generator, transformer, and ATM card. This was my demo class. Thanks for your time. Have a nice day. Allah Hafiz.